Okay, so what we were talking about is how do we understand what are the cyber assets look like, and then our intention is to understand and identify how many of those are critical assets. So apart from looking at this these points where we look at control systems, data acquisition systems, networking devices, hardware platforms, we also need to look at certain roles and functions. So there might be intermediate entities, devices, processes that could be crucial for a system. Yeah, for example, you can look into some of the functions that provide operation information in real time, right? Let's say there's a dynamic pricing model where you can, so there's a system that there you get to see what is the current price at this point of time if you want to charge your vehicle, right? So that channel itself is a very crucial. What if someone disrupt it? You don't able to see this, right? Similarly, there could be function that controls manual automated parameters. Parameters might have certain construction, certain constraints, limitations, restrictions. There might be some devices that gives you a visualization display and so on. Connectivity, so in terms of communications, how what different communications are for operators, for system engineers, for users, and supports continuity of operations or a local recovery plan. So backup plan, for example, backups, redundancy of data, and so on. So they're all part of kind of critical asset, right? Because when we believe, for example, when we say there's a bank that every day they have backup, they create backups. What if you don't have backup? Or someone control your backup, delete everything. Yeah, so it's not just about the system that we are working on. Those backups and other functions are also crucial for us. So all those we consider as primary assets. Then we got some secondary assets, which are not directly part of the system, but they are part of supporting system. One of them is, as I said, backup, UPS. Yeah, in terms of when you don't have electricity, you can still work through UPS. Environmental support. If you're working in a hot area, you need air conditioning, right? Sometimes we need exhaust, sometimes we need cooling systems when temperature goes really high, especially in machinery. Every big machine that comes with cooling system that can cool down the machine if you're using it for a longer time. Standalone malware and virus scanners, backups, restore systems, log monitoring systems. They all are important because they're not directly part of the system actively, but then passively they help us detecting threats, recovering data, create backups, plan, and so on. Sometimes we do keep some device and assets in storage. Something goes wrong, we can replace. We have backup of those devices, right? Softwares, whatever. So these all are part of secondary system, which also somehow crucial for us to have in case of unusual activities, right? So that we don't, we are not out of service. It's not like system is down. We can still manage with the secondary assets that we have. So it says once you identify all the assets, you group them. And then once you are grouping them, again, it depending on what criteria you're using to grouping them. Sometimes we group them based on the operation side, right? In order to operation one, we need different type of devices and how they are kind of part of the system. So you group them maybe based on the operation, based on the functions, and so on. Software they are using. Once you are able to do that, then you need to identify which of these are essential, or critical to us. So, for example, First is a cyber asset capable of supervisory and autonomous control, which is essential for us in this process. If you recall what we had a Purdue reference model, in that sense, supervisory control system is very essential for us, because that is the system that can help us fetch all the data, run it, process it, yeah, from the device, and you can also control those devices. So supervisory control system is really essential. For example, display, transfer information. So we need sometimes display devices, HMI, human machine interface, to observe certain quantities. We might need communication channels, right? How to send that decisions to the devices, to the users. And obviously, we also need to look at the assets that has kind of impact, negative impact. So if there's any negative impact on the devices, that might have direct impact on the system, right? So let's pick one of the examples, though the answer, you can see the answer, but I would like you to think about them by yourself. Yeah. For example, so this is an example determination of cyber asset supporting reliable operation for transmission substations. So when I say BPS, we are talking about bulk power supply. Yeah, power supply, just say. So this says security guidelines for electrical sector, identifying critical assets. Number 1, essential to bulk power system restoration, essential to critical generation, essential for voltage or frequency support or stability of the system. Now, one is I'm using telemetering. So telemetering is used to measure the quantity, pressure, and depending on what devices we are talking about. Now, there are 3 parameters, there are 3 criteria you see here. First, it says used in supervisory or autonomous control, impacting reliable operation of the critical asset. The other says display, transfer, contain information relied on to make real-time decisions, impacting reliable operations of the critical asset. And third, say loss, degradation, and compromise impact on the reliable operation of the assets. So if you have any telemetering device, device, is it critical for supervisory system? Now we are talking about OT system, yeah, we are not talking about IT system here. Is it critical? To the supervisory system? I said no, it's not. Why? Why? Because as I said, even if you're measuring something, let's say if you're measuring power, how do we measure power? What is the unit? Okay, let's say what. So yeah, so we generally, in this case, we generally measure in megawatt. Yeah. So let's say if you're measuring a unit, and at point of time it says 20 megawatt, and suddenly it becomes, when you're measuring it becomes 21 megawatt. Is it really crucial to know this when we are feeding to supervisory system? In OT system, it's not. Why? As I said, even if you're passing incorrect value, having incorrect value does not help you. It might help in IT system, but it will not help you in OT system. Exactly until you pass it to your SCADA system, run the algorithm, and observe the outcome. That's why telemetering is not critical or essential element in this one. For display, if you're showing these values, someone is observing these values, they are essential for someone to know it. Yeah. If there's a screen where users are monitoring things, it's essential part. Loss, degradation, compromise impacts on reliable operations. Yes. What if you don't receive measurements? Yeah. Signal lost. Then obviously it might have an impact on the real system. RTUs. Remote terminal unit. What is the role of RTU? These are the devices deployed at substations. They are sensing, fetching data from all other devices and sending to the control center, right? And when I say sending to the control center, they are sending to SCADA system. SCADA system feeds all the data and run the algorithms. So RTU is essential for SCADA systems. Yeah? If there's no RTU, you don't have any data. Is it part of this real-time decision making? Yes. Once you run algorithm, then you get to see the outcome and then you make certain decisions. Is it part of compromising this will impact the system? Does it have impact? So yes. Right? When someone compromises data or RTU has direct impact. Then it got substation automation system. So normally comprise of multiple cyber assets. So substation automation system, does it have impact on supervisory control system? Yes, because we are talking about all the devices there that are sending their data to the RTU and then RTU further transmitting them. Are they used in real-time decision making? Yes. Right? If you don't receive data, you won't be able to make correct decisions. And then loss, degradation, or compromise impacts? Yes. Okay. Protective relay. What is relay? Relay could be the way we think about MCB, right? It can trip down, trip up. So used in supervisory control. So yes, that's how you run commands to open lines, right? Open line means open circuits. So how electric circuit works? What does it mean when we say MCB trip down, or what does it mean? What happened? It breaks the circuit. When you complete the circuit, current starts flowing it. Once you break it down, there's no flow current. Yeah. So as simple as that. So we do use relays in power systems as well that help us control the system. When there's a need, when there's an overload line, we want to trip down. If you don't trip down, it will destroy your component. So we do use those relays. Obviously, at the time of supervisory control, when you are feeding data, you also need to know which lines are open, which lines are closed, and so on, right? Does it help in making real-time decisions? Yes. That's how you got to know if there's a demand in certain region, and if this line is open, you want to close it, make the circuit so that supply can be provided in that region, right? Does it compromising this, does that have impact on the system? Yes, and if anyone can control your circuit breakers, relays, they might misuse it. Then you go to spatial protection system, part of SCADA system, obviously yes. Do they use real-time decision? No, because they are more reserved thing. They're only active when it needs to be. But then while you are making decision, you need to know whether they are active or not. Yeah? But they only works in certain situations. Compromising those will impact the system? Yes. So if someone compromise your protection system, there are serious issues. Phasor measurement unit, PMU. So PMU are devices which measures magnitude of power quantities, right? Voltage and phase of it, current. Now, as I said, they are not essential to know. It's good as we have phasor measurement units, I mean, earlier these devices were not recognized even part of the electrical system because their role is just to measure it. And by measuring things, you can't really say whether having change in certain amount will have any positive or negative impact on the physical system. So that's why they are not being considered as essential element or asset part of the system. Historical long-term database supporting off-site storage. Having a historical data set or logs, does it require for supervisory control? In a normal operation, you don't need it. Generally, logs are there when things go wrong. Then we look at logs, and understand where's the fault, what happened, and so on. But in normal operations, we don't really need them. Similarly, will they help us in making real-time decisions? No. Generally, they can help us in preparations, in plans. For example, if I wanted to know what will be the forecasting for tomorrow, load forecasting, what will be the demand in that particular region based on, I can look into historical data and then understand, right, the patterns. But they are not part of my real-time decisions. Compromising logs will affect your real systems, real operations? No, right? Might be you will end up with having poor planning. You might not be able having correct forecasting, but then it doesn't impact your real systems. Similarly, you got fault records, equipment monitoring, the same. They are there, but they are not part of real-time systems. Then computer networks that connects control functions between assets within a single ESP. Computer networks, yes, because they are part of the system. If something goes wrong, then we might not be able to collect data. For example, when RTO is sending data to the SCADA system, it comes through communication channel, and in between we might have routers, we might have switches and other devices, right? If someone compromises those devices, if devices are down, we won't be able to have those values. So they have direct impact on the system in all three. Oops. And then you go station computer or workstations. HMI, right? So HMI is the one that people sitting at substation, they look at the screen, HMI, and based on that they can send certain commands, right, to the devices there. So it's a part of your operations. Again, it's a broader picture where they have done some study around. Apart from these three, they also look at communication side. They also look for routing protocol, dial-up accessibility. What is dial-up? What is dial-up connection? Now you see there's always Wi-Fi, internet available. Yeah. And 20 years back, there was no Wi-Fi. People used to connect internet using telephone lines, and that's what is called dial-up connections. Yeah. So there was a wire coming from telephone lines that you connect to your system. There's a certain number reserve. Give you user ID, password, then you connect. So there's a screen popping up. If you have telephone lines, if you don't, you can't. So it's an older system. Now we got Wi-Fi everywhere. Right. So for example, we look at this SCADA supervisory control. It's a primary control, right? So it's all the primary control. State estimator. So what is state estimator? State estimator is one of the power system algorithm that, so when I said when you sense data, RTU sends all the data from the field, send it to the control, send it to the SCADA system. SCADA system pass all the data, run the algorithms. One of the algorithms is called power flow, and we have something called state estimator that will evaluate the current state of the system. So they will look into the power quantity, voltage, current, and do some calculations. So we do have state estimator for that purpose. So they are part of this. Some state estimator also have that functionality where if the data is incorrect, it has capability to correct the data to a certain extent. Yeah, so it's an active part while you are processing your data. Print server. Is it crucial for real-time operations? Is a printer a crucial system, essential part of your real-time system? No, right? It's there just to facilitate if you need to print something, but it's not part of your real system. So that's why it says it's not a critical asset. Right. Does this help? Did they have this exercise? Okay, so let's talk about a few more things. Critical, first of all, once you are able to identify critical assets, it's help you to understand out of the big pool, which are the assets or component that you need to focus on. Obviously, security is a holistic thing, but you don't want to lose the key elements of your system. Some of them might be very, very costly, right? You also want to get into the understanding around the environment, because sometimes people, if I'm working in a power system company as a cybersecurity expert, for example, I might not have understanding how many assets they might have. Yeah, they will just expecting me to come in there and fix their problem. But in order to fix it, you have to have the holistic view of it. You need to understand what devices are there, what are the connections there, which devices there which are connected to internet, right, and so on and so forth. So understanding the holistic view, understanding the environment will really help all of us, isn't it? For example, you come to the university, and maybe you are studying something that is having loads with mathematical equations and so on, right? The person who is teaching might not be an expert of mathematics, but they understand how things work. But you want more detail. If you understand that at this university there is a mathematical department, there is someone, Professor X, yeah, understand all these things, maybe can help you better. If you understand the environment, you are working on this topic, you might need this electrical engineering department, somebody is working on power system, right? They might be better explain what is called state estimator, what is power flow, and so on, because they've been working on this since very long. So it's a very simple way. If you understand the environment, it becomes much better for you to think about, plan it better, yeah, in case of emergencies, in case when you need it. So in a very similar way, understanding the environment is the key. Director of an institute knows everything, how many departments, what they are working, blah, blah, blah. That's why he's the person who can make certain decisions, in fact, correct decisions. If you have to make a decision on the basis for this institute, you need a lot of information before you come to a point where you can decide what to do. You can't just decide based on what is happening in the computer science, right? So you need to know the whole environment in order to understand it, making correct decisions. Obviously, you can optimize it. You can fix the vulnerabilities, patches, and so on. Determine the best maintenance windows. So we talk about how difficult it is to maintain assets, but then also from cyber point of view, when you need to apply patches, you can't apply at any time. You have to plan it well. Maybe at the time when you see the maintenance, you need to offer maintenance to some of the devices, but that might be the time when you want to apply patches or so. tailor protections of sensitive data. So as we discussed, in some sectors, data could be really sensitive, especially in healthcare, finance sector. If we are working on those cyber physical systems, then there could be additional layer of regulations that you have to adhere. You have to follow those regulations. And sometimes as a company, you don't understand those regulations. Regulations are very vague. Yeah. So you need people who understand those regulations, understand. So again, data management is, again, it's a broad topic. For example, what most of the companies are doing, collecting data. If I'm a small company, I don't have cybersecurity expert, and if I'm collecting data from, let's say, European people or whatever, I'm bound with GDPR, right? I know if the data is leaked, I have to pay 4 billion euros, 4 million euros, which is a really high amount, right? So in a way, if something like happens, you won't be able to do any business with those countries, because they will ban you unless you pay it. So what's going to happen? I might think of putting the data in the cloud. That's what most of the company doing, yeah? Saying we have a lot of data, we have very large data, that's why we put in the cloud. Whenever you need, you can use it. What is cloud? What is cloud computing? Okay, so we have basic 3 models. Okay, there could be public cloud, there could be private cloud, there could be hybrid cloud. Public cloud, where you pay really less, but your data is on a public cloud. People can access it. Private cloud, which is more customized for you, you have to pay more. Yeah, and then hybrid combination. Now, when we say putting data on cloud, I have Amazon Cloud, Google Cloud, Microsoft Cloud, all big companies offering this service. Putting data means generally they have one system, server, they're putting all the data there from different companies, right? If there's a data leak, if there's an attacker that can have access to the server, can compromise data not for just one company, all the companies that are having their data on the server, right? Now, companies are also offering these models in three broad categories. One is called software as a service, SaaS. What does it mean? Yeah, so software as a service, platform as a service, and infrastructure as a service. What does it mean? Software as a service, what it says? Software as a service simply says, as a company, I have my own software, you can use it. That's it. It's all my platform, my software. You can use it, and you might keep your data on my public clouds. Public clouds are risky, maybe no security or less security. Yeah? But they are more dependent on the company. If those softwares are down, you can't do anything, you can't access your data. So they are the cheapest one, but then they bring a lot of risk. Then they say second is called platform as a service. What is that? Right. So you can use my platform, you can customize your software, you can create your own software and use it. So you have to pay little cost to it. But they are more platform dependent. Once there's that company out, whatever you build is out. As simple as that. Right? Third says infrastructure as a service. What does it mean? Infrastructure as a service, they say you can use some part of our infrastructure. You can build your own platform. We will support you. In worst case, because of the cost. So let's say if those servers or data centers are really costly. Small companies cannot afford those. That's why maybe you can utilize our infrastructure, build your own platform, build your own tool, build your own software, use that. So that is the third category. Now the question here is, if I'm putting my data in cloud, right, any of those models, let's say there's a data breach happen. Someone get into the system, compromise data, and leaked it. What will you do as a company? You say nothing. You're collecting data from customers. If you don't do anything, the customers will start blaming you. They'll go to the court saying, you know, this company has used my data, they have leaked my personal information. You have decided that you want to put your data in cloud. Your customer did not. Customer is still believing that you are the one who are storing your data, right? In some of the cases, for example, if the data breach happened at my organization where I kept all my data, I might have asked for forensic investigations. What happened actually, right? I might hire people who can come in here and find out what was the cause of data breach, which is doable in a way. Obviously, it comes with cost, but it can be doable. What happened when you put data in cloud? Do you think the company that holds your data will allow you to do the forensic investigation? No. Will they do any forensic investigation by themselves? May not, depending on what pressure. If the just data leak from your company, might be they start blaming you. You didn't manage it, whatever. If data from multiple companies release, even despite of that, they decided that they want to do investigation, they'll hire someone, do some investigation, and simply blame you. They'll hire people who can create a report as they want. They will not take blame on themselves. So putting data is kind of a dark side of it. Right? When you do this, generally we have something called service level agreement with those cloud providers. SLA we call it. Service level agreement says, it's a long agreement which says how you keep your data, my data, how long you keep, where you keep, what security method you will use, blah, blah, blah. Now, if that cloud provider also not complies with those regulations, you are the one liable for it because you have decided to put your data there. So before you do that, you want to make sure that they will follow these regulations. And there's a proof that they will give you. Otherwise, the company who collecting data is responsible for everything. You are the one collecting data. Whether you manage at your end, send to someone else, whatever you do. But if something goes wrong, you are the liable. Your company is liable to this. That's why storing data is not straightforward things, especially if your company collecting large amount of data. And you don't want to take that risk at your end because you think maybe Microsoft has much better security than my company, or Google might have better security, which may be the case, may not be the case. Because if you look at the data breaches, all the big companies being hacked, whether it's a LinkedIn, Microsoft, Google, whatever. Right. Now, if I look at critical assets, I can divide into 4 broad categories. One, data. Data is very, very critical. Right? Not for just cyber physical systems, but for any kind of systems. Even the company, as we said, Facebook, your social media platforms, Instagram, whatever, they're allowing you to use free of cost. Is there any other software that you can use free of cost which is not open source? Generally, no. Yeah? That's how company works. They will ask you to pay something to get their service so that they can survive. They can run out of it. They can manage things. But if they are a company, they say use it, we don't need anything free of cost. That means they have some hidden model. They have their business model that people cannot see. And that business model is data. They're collecting all type of data from you, processing it, selling it to the companies who need it. Yeah, they're sending to the financial institutions, saying, "Oh, this person has car, this person has house, this one, go and ask for insurance." So they're selling to insurance companies. They're selling to other beauty products. Someone is searching XYZ, customizing those advertisement, right? You're getting calls, you're getting emails, and other things.
In this case, we can take the example of Cambridge Analytica, Facebook.
Yeah. Yeah. And these companies, that's what I'm saying, like this is individual impact, but these companies and this data is so powerful, it can influence government, citizens, people. Right? There's always claim that Twitter was involved in US election, blah, blah, blah. What? And that's what the other day we discussed about deepfake. You can generate a lot of fake content, and the content is so large, people start believing this is the real content. Yeah? So those companies, their revenue generated by data. If you decide not to send their data, they will be panicking. But the people like those things to share. Facebook, whenever you got new car, you just click it. Yeah, not just your family, your functions, your moment, everything is there. Your friends, and they know what is the circle they need to create. Which are the people who look businessmen, So they create the customer. They use that data to create several groups, and then selling to thousands of companies. And that's why they are in a much better position. They're so profitable companies. So data is the future, and that's why we're saying large data, good or bad. What do you think? It's good and bad in both sense, right? When you develop machine learning models, we say if the data is large, you can do a lot more testing, you can rely more, and then your models can, their prediction will be more accurate. If your data is less, that means you haven't have data from all different types, and it might not work on the system or the data that not part of training set, for example. Large data, again, difficult to manage, but then it has pros and cons. If data is incorrect, deep fake, it's not bad. It's not good, yeah? People, you might see that these machine learning model end up with training with those deep fake. So if you are not able to identify which data is correct, which is malicious, you end up with training your data with malicious data, right? So you're automatically creating a backdoor entry for people to misuse it. But in societal system, it's very hard to understand what is right or wrong in terms of data, right? Sometimes things work with logic, sometimes things work with emotions, and there's always trade-off. Yeah. Okay, so data, people. Now, in an enterprise, you might have people with different roles in different numbers. Some people might have that understanding. Some people might not have understanding about cybersecurity, but there might be people who are sitting at crucial points. Right? So if those other people don't have cybersecurity, you need to train them. It's important that they should know their responsibility, what to do or not to do. Right? Network infrastructure, we talk about all of those things, whether it's a control system, networking devices, supervisory control, acquisition systems, and so on, and application infrastructure. Within infrastructure, you might have number of applications for different type of users, for different services, and you don't want to You don't want to happen that at some point some of those devices are down, or sorry, applications are down, right? So for data breach, the problem could be for data it could be data breach, manipulation of information, and corruption of data. What could be the control? You apply data protection. Sometimes people say encrypt your data. Even if data hack, it's still encrypted, right? But then we got new kind of ideas where people can compute things over the encrypted data. They can still sense something out of it. Data recovery capabilities, boundary defense, people, someone pretend to be someone else, identity theft, man in the middle attack, social engineering attacks, abuse of authorizations. If I have access to this building, I can give through card, I can give this card to my friend, can enter into it, yeah? Earlier we used to have that token physical card as a second factor. Now we have replaced this with our own devices, one-time passwords and so on, right? Network infrastructure could be denial of service, manipulation of hardware, botnets, network intrusion, malware. What is botnet? It's a network of bot. What is bot? A digital assistance, kind of, yeah? Nowadays, when you go to a site, it will say, how can I help you? Tell me your name, blah, 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 yeah? It's automated. It's a system which kind of programmed to answer some of the basic things. And if this assistant thinks it cannot answer it, it will say, I'm connecting you to one of the agents, yeah? Please hold it or wait it, whatever. So there might be bots available, but these bots are having security issues in that. So I don't know if you attended one of the conference talk that I did on 8th, where I talk about dozens of story how people, the companies created their bots and how did it go, how it went wrong really. So when you are creating a bot, you expect this bot to answer a few things. And that's what the aim in terms of company's perspective, that they want to replace humans with this bot, right? But then bot might not be able to provide you correct information, or it might have bug at some point. And during those instances, they found that these bots cannot replace humans unless you train them with the larger data set, right? So these bots could be point of compromise. All right, network intrusion malware. How you control it? So first is say control of privileged access. You want to control who can access and what permissions, and more specifically for social sparing, social engineering techniques. Make sure we understand what is phishing, what is spamming, how to avoid, and so on. Monitoring of audit logs, looking at logs, possibly we can get a sense what has went wrong, and then trace it back. Malware defenses, depending if you are able to understand what type of malware it is, possibly you can apply some of the solutions. Network controls, you can reconfigure things, isolate system, block the port, right? So for example, yesterday we looked at client server model, connecting on the same port. If you think the client is malicious, you can block that port, the server, so nobody is able to connect it. Inventory, secure configuration, continuity vulnerability assessment. Application infrastructure, someone can manipulate your software, unauthorized installation of software, misuse of information system, and denial of service. The key control could be email web server protection, application software security, secure configuration, and so on. Now there's something called residual risk. What is residual risk? So at the end of each of these control, it says additional control for residual risk. It says despite of applying your security solutions, there's always risk. There's always some risk left over. that we call as residual risk. Right? We might figure it out by the time or when someone exploits it. Then we need to take certain extra control over it. Okay, do you want to stop here or? Okay, so let's stop here and then I continue in the afternoon session where we talk about kind of a summary and some other interesting thing about these. So we touch about almost everything in the understanding critical assets. But I'll give you some insight based on what did we do. So I do have a number of PhD students also working in this area, so I'll give you a sense what we did, what type of research and what kind of outcomes they look like.